and get started. Hello everyone, welcome. My name is Craig Shallenhammer, and for this presentation I'm going to be talking about identifying the high-risk SQL before the upgrade, because we all know it's a lot easier to identify the SQL after the upgrade. How we're going to do that, that's the focus of this presentation. Now the truth is, anyone who's honest is going to tell you that it is impossible to match a quality assurance test system with production. It's just not going to happen. Now they might not tell you this initially, especially if that's the focus of their job, but the truth is, and they know it, it's not possible. Well, why not? There's a lot of reasons. Differences in hardware. I don't care if you are replaying a transaction one after another. It's not going to happen. You can have just a slight differences in the volume. Now, before we get into that, I want to introduce myself. My name is Craig Shallenhammer. I'm a long-time Oracle DBA, and I specialize in Oracle Database performance and predictive analysis. Okay? I do a lot of performance research, and therefore I do a lot of blogging as well. And I'm also the author of a couple books that I'm very proud of about Oracle performance and predictive analysis. I'm also a conference speaker, I'm a teacher, a mentor, and I'm also an Oracle ACE director. So that's a little bit about me. My goal in this presentation, I want to be able to identify SQL that is likely to perform poorly in the upgraded environment before, not after, the actual upgrade. How we're going to do that, it is really tricky. Here's just one example. Should we upgrade? A SQL statement runs 30 seconds in QAT and it runs 20 seconds in PRD. Is that a big problem? Well, some people might say yes, but what if I told you that in production the CPUs were twice as fast? So here's the plan. Here's the plan. So we come up with what I like to say some unorthodox or non-standard ways of identifying high-risk SQL before the upgrade. The first thing is we've got to understand that there is a relationship between work and time, because that is going to flow through everything that I'm going to be talking about. So we've got to be settled on that. So I'm going to start with that. Next, then we're going to look at a way to fundamentally, in a sense, profile two different systems. You see, if your QAT system and your production system are fundamentally different, like one's CPU bound and one's IO bound, well then if you just compare SQL elapsed times, it's going to be meaningless. Meaningless. So we need to first get past this profiling the system. The other thing that we're going to look at is how do we deal with CPU speed differences. Very common for one system, particularly production in a QAT environment, to have different CPU cores. Not just the number of CPU cores, but also their speed difference. I'm going to show you how to eliminate, in a sense, that difference to standardize the CPU speeds. Pretty cool, and it works great. Next is we're going to look at dealing with when the workloads are different. And this is an extremely difficult one. I'm not going to give you like a step-by-step, here's how you fix that. But I am going to show you how to identify where there are differences and the things to look at so you're not fooled when the workloads are not the same. And then I'm going to end with what I think is probably the most valuable part of this entire presentation is how do we deal with identifying the SQL when it's really not so much about the SQL ID, it's about the business scenario or the business function. In a true, what I'll say, more of a production-like workload that's being placed on our QAT system. So that's the plan for this seminar. We're going to start with work and time. And each logical I/O takes about 0.02 milliseconds to process. So I have the work and I have the time to process each piece of work. What's the elapsed time? 2,000 milliseconds or 2 seconds. It's just like candy. How many pieces of candy? How long does it take to eat each piece of candy? But how long does it take to process each piece of candy, or each logical I/O in this case? Well, we take all the time For example, if one system is I/O bound and the other is CPU bound, I mean, they're very different systems, and we would expect the same SQL ID, the same module, to have a different elapsed time or to consume different amounts of CPU or I/O. How are we going to do this? Well, with just a standard AWR or a stats pack report, we can do what I call an Oracle time-based analysis. When I do this profile, I ask myself, are the characteristics the same in terms of time? Are the characteristics the same in terms of the workload? And if they're different, then I need to expect the elapsed times for the same SQL ID to be different, right? In other words, I shouldn't be surprised if I actually see that. This is very common, right? You're not going to have the same speed of CPUs, the same quality of CPUs, right, in your QAT than your production environment. This is very, very common. If the SQL elapsed time is different in QAT, it's not because of a CPU speed difference. So how do we account for this? How do we deal with that? Well, that's what I'm going to talk about right now. I have a tool, and I call this just the ORPUB CPU speed test. You can download this off my website. It's free. It's in PL SQL. It works really good. And the beauty of this is it actually runs Oracle code, right, on a real operating system. It's just not some... Here's the situation. The SQL runs for 30 seconds in QAT, but it runs for 10 seconds in prod. So is this a problem? I mean, it's 3 times as slow in QAT. So does this present a problem? In fact, specifically, how do we deal with workload differences and workload intensities and workload mix differences in our production and our QAT environments? Because if the workload is different in one of the environments, making an apples-to-apples comparison is not straightforward. In fact, in other words, it's running slower in QAT than it is in production, and the DBA is freaking out. Right? But you know better. You say, well, of course it's increased because the test environment's workload has increased. Now, there's a lot in this little table right here, so we're going to go through this step by step, and I'm going to go left. Okay, now why did the response time increase? That's the kicker here, right? Why did it increase from 0.01 to 0.02? They're touching the same number of blocks, but it takes longer to run because the overall system is busier. In fact, it's so busy, everything just kind of slows down. But I'm still touching like 100,000 blocks or a million blocks. What's changed is the time to eat the piece of candy. And what caused that is because the workload increased. Let me give you an example related. In fact, the workload intensity is so much more in the test, it was kind of, the response time was kind of pushed up into this elbow of the curve. So here I have 4 ways to help you understand if there truly is risk related to the whole workload thing. First of all, at an instance level, or what if it's about a business scenario, and some of these different scenarios run different SQL IDs, or the same SQL ID, but they have different bind variables. It gets really, really difficult to assess the risk when this actually happens. So we're going to get into that. So here's a real life situation that I've actually personally found myself in this situation. There are many different load situations. And like a real business, the load situations don't start and stop in nice, clean AWR snapshots. Right? Now, that's good news, but there's even more bad news. Okay? This is not a good enough approach, and it's because the module in action may be acceptable to run 60 seconds in one situation, and it may be acceptable for that same module action to run in only 10 seconds. Take a look at the data collection script. If you're familiar with AWR, you're going to recognize this, immediately. I'm going to look at each one of these sample sets independently, and then I'm going to put them together, and we're going to see if they're similar enough to say there's no risk here. So let's take a look at the production sample set. I created a histogram using R. In fact, all the stats I'm going to do, I'm using a free statistical package called R. What I wanted to do is I wanted to statistically compare these. Visually, it looks like they're pretty much the same. Statistically, I needed to do what's called a significant test. Okay? Now, essentially what I'm doing, when I compare two histograms, two sets of data, is that if they are exactly the same, like let's say my hands are histograms, and this seems to work really, really well, so I can truly identify risk at the module and the action level in a business-centric situation. Now the truth is, it's impossible to perfectly match production. However, with what I talked about though, there is a solution. There are ways to assess the risk in a situation where the production and the test environment don't look exactly the same. And so we started off this journey in a sense by understanding work and time. Thank you all for listening. I hope you've learned some ideas, some additional skills. You got some value out of how you can actually find and identify the high-risk SQL before the upgrade as opposed to after the upgrade. So thanks for listening, and I hope you have a great rest of the conference.